Right, if you want to just get into it and look at the actual solutions and everything, then there'll be a timestamp probably on the screen, or you can just look at the chapters in the little red bar. Yeah, and each question will have its own chapter, so you can just go to whichever question you want. The paper we're covering is June 2018, paper 1, and the way I'm going to do this is I'm going to do it as if I was doing the paper myself. So it's likely that I may make a mistake, and so after each question I'm going to go over the mark scheme. If I make a mistake, I'll correct it and explain why maybe you could make that mistake, or how I made that mistake, and how to learn to not do that mistake again. Yeah, so I hope this video is just useful for people who maybe don't know how to approach some questions, just maybe know some of the things but don't know how to use them in exams, for example, or for just people who want to see someone do it. And I'm trying to make this a bit more in depth so that people can kind of understand my thought process, and and also I'm doing this for revision because the best way to learn is to explain. So yes, anyway, let's just get started. Question 1. So looking at this question, it's these first few questions aren't going to be difficult. They're all going to be like 1 mark, but you can always time save on these kind of questions. There's usually a better way to do something. So looking at this, you see the fraction and you may think, oh, well, I've got to differentiate using the product rule. Whilst this will give you the right answer, it's not necessarily the quickest way. For example, looking at this, I see there's only one term on the bottom, so I could easily rewrite this as x to the minus 2. Because that's exactly the same. And now when I differentiate this, it's much easier because all I've got to do is I've just got to bring it down, bring down the power and decrease the power. Now obviously that exactly is nowhere to be seen. However, that can be rewritten. So the same way that we converted from a fraction to an indice, we can convert back from an indice to a fraction. So you get minus 2 over x cubed. Nothing complicated, but it's just it's quicker than writing out u equals 1, v equals x squared, and then doing the product rule, the quotient rule even. I don't know why I said product. But yeah, so that's our answer there. And if we look on the mark scheme, yep, that's pretty straightforward. Next question. So the graph of y equals x to the 5 to the x is transferred by a stretch in the y direction with a scalar factor 5. State the equation of the transformed graph. Okay, so this is just, do you know how stretches work? So first of all, y direction is important because that just means you take the function as a whole and you're doing something to it. You don't actually do anything to the x. And scale factor 5, that just means you're stretching it by 5. So literally all you do is you times the function, which is 5 to the x, by 5, because you're doing a stretch with your scale factor here, and it's on the in the y direction, so you just do it to the whole function as it is. So yeah, so your solution is there. I guess looking at some of the other solutions here, we have this is a stretch on the x-axis by 5 because you're dividing x by 5. So the way to remember this is if you're doing something to the y-axis and you're stretching it by some amount a, let's say we have some function, right? If you're stretching by a, then you're just timesing it by a, okay? On the y-axis. If you're stretching it on the x-axis, you have to actually divide x by that amount. So stretching by x, you would have x over a. So if you're stretching by a factor of a, you divide by a. Now, if the opposite is true, so when you're stretching by a factor of 1 over a. So if you're doing it on the y-axis, it's just 1 over a times your function of f. Or, in other words, squeezing it by a factor of a. Stretching by 1 over a is the same as squeezing by a. And if you're doing it for the x-axis, you're timesing it. Now, if you want to remember that, sometimes it's not a bad idea to draw a graph. It doesn't have to be the graph you're trying to sketch, because if I did the x, whilst it's not really that difficult, you know, it's just that. Sometimes maybe just try it on y equals x and see what different things happen when you plug in your different transformations. And that might help you understand it a bit more, and then you can, you know, go ahead and solve. But as a general rule of thumb, I don't think these 4 sets of rules is too difficult to understand. You know, after a few practice runs, I'm sure you'll get the hang of it. But yeah, so typical solution, 5 times 5 to the x. Okay, question 3. Periodic sequence is defined by un is sine pi n over 2. State the period of the sequence. Sketch. Circle your answer. Okay, so a period, if for some reason you don't know what that is how long until it repeats. So I guess a very inefficient way you could do this is by plugging in different values of n until you get the same value, and then finding how many terms you have there. But the better way to do this is, you notice that you have sine, which sine of x is periodic because it repeats after pi over 2. So the way to figure this out is x in this case is not pi over 2, but it is actually n pi over 2. And so every n, you're stepping by pi over 2, you know, you're stepping forward by pi over 2. So to visualize that a bit better, maybe, if I draw sine of x, so here we have sine of x. So when n is 0, we have 0. When n is pi over 2, we have pi over 2. And n is 2, we have pi, which is there. And I'm sure you can see the pattern here, 3 pi over 2, and then pi, 2 pi. Now, something you could be careful here, you have to be careful about here, is when n is 0 and n is 2, which is when here and here, you can see that it has the same value. But that does not mean that that is its period, because when you then continue, you have a different value. So you go 0, 1, 0, minus 1, 0. And then that's when it starts to repeat. So you can't say that it has a period of 2. You have to say it has a period of 4, because the value afterwards is not the same. So if I were to write out u to the n, we can see it's going to be 0, 1, 0, minus 1, 0. But you can see the first instance of 0 repeating is here. But of course, then it's not you'd expect 1, but it's minus 1. So you can't say that that period's there. So you got to say this is the period. This is when it starts repeating. So like after this, it's going to be 0, then it's going to be 1. It's going to be minus 0 again, minus 1, 0. It's going to repeat. And so the period is 4. Function f is defined by f of x is e to the x minus 4, where x is in the set of real numbers. In case you don't know what that means, real numbers is just anything that, basically all the numbers, all the standard numbers, because in A-level maths you don't really come into imaginary numbers, you really only just work with real numbers. So it basically means any number. Find the inverse of x and state its domain. Okay, so first of all, when you have two things like this, you want to try and do the first one and then the second one. So doing the first thing. When you're trying to find the inverse of a function, I find it very useful to just swap the variables. So f of x equals e to the x minus 4 can be written as y equals e to the x minus 4. So I'm just going to write the inverse. So x equals e to the y minus 4. So what I've done there is I've gone from y equals e to the x minus 4, and I've just swapped the x and y. If you have multiple x's and y's, you've got to swap them as well. Yeah. And then this is just a process of trying to make y the subject of this equation. So first things first, we have an e, which means we have to get rid of that e. The way to get rid of the e is to use ln. So ln x equals ln e to the y minus 4, which the ln and the e cancel, which is y minus 4. Next, it's just simply put in plus 4. So ln x plus 4 equals y. Now, it's not asking us to find y, it's asking us to find f to the minus 1 of x, which is simply just, you write f to the minus 1 of x. Just for, like, completeness. Another mistake that sometimes you could make, in case you're, like, not paying attention, is you're thinking that, oh, f to the minus 1 of x, that means 1 over f of x, which, no. If it was written as f to the x, and then that to the minus 1, that's a different story. But you got to be careful of where that minus 1 is. Just a small thing you got to be aware of. Okay, we still got to find its domain. So in case you don't know what domain is all of the values of x that are acceptable. So the usual rule of thumb is the range of a function is the domain of its inverse. So if you were to look at this original function f of x equals e to the x minus 4, let's try and find out what that range is. Okay, so how do you find the range? Well, usually I think the best thing is to try and draw the graph. First thing to do is to draw just a normal e to the x graph. If you want to go straight to the e to the minus x 4, that's fine, but that's your usual graph shape. Now, the thing that's happened here is it's being translated by 4. So the question was, well, this part of the question, we're trying to find the range of y equals e to the x minus 4. And I drew the e to the x graph, which, oh my god, it's like that. I was actually going to say that because it's minus 4, you're translating to the left, which is incorrect. When you're taking away a value, you're translating to the right. So I guess I'll show you all the cases in terms of some function of x. So if you're translating to the right, you're actually gonna take away that value. Now, if you look at why this is, here we've got y equals x, roughly. If I were to find the value when x is 1, that's going to give me y equals 1. Now if I want to shift that graph by 1 to the right, now when the value is 1, when x is 1, we want the value for when x was 0 from the previous graph. Because we don't want 1, we want y to be 0. So how do we relate those things? Well, this new value is 1 greater than this old value. So to go from this new value to the old value, you take away. And that's why this, because we translated this by 1, the x is replaced by x minus 1. So this translates to the right by a, and then the opposite of opposite is true when you're translating to the left. It's it's just the opposite. In terms of if you're trying to do it on the y-axis, then you're literally just either adding that value if you're shifting it up. So really, if you look at the equation for y equals x, if I want all the y values to go up by 1, then I just got to add 1 for, I just got to add 1, because y is now whatever it was before, but plus another 1. And so if you're shifting up by a, that's that. If you're shifting down by a, you take it away. And that's kind of just all you need to know. Sometimes if you have a more complicated function of x, I don't know, x squared, it's best to substitute it with brackets. So if you're shifting, I don't know, to the right by 5, x minus 5 all squared. Just to make sure that you substitute for x and you don't do something like x squared minus 5, because that's not the same. That would be, in fact, if that was just a function itself, that would be a shift downwards by 5. Hopefully that clears the transformation of graphs a little bit, and we can continue with the video. The range is what values of y can it take, and just by looking at the graph we can see that y, or f of x, is got to be greater than 0, because e to the x is never 0. So then intuitively you'd think the domain of f to minus the inverse of x is also greater than 0, but there may be an exception. I don't think in this case it applies, but it's always good to check. But you can always do it a different way. If you look at this function, the domain is basically what values of x can you take, and you always start off with x can be in any of the real numbers, because that just means it's any number, and then you write some condition if there is one. So here we have 4, which is a constant and has no x at all, so that's fine. But ln of x. Now ln of x, if you were to draw that graph, you can see that there are no values of x below 0. In case you don't know how to draw that graph, I mean, you don't really need to. I'm pretty sure it's really good to know these special functions. They're like limits and boundaries. So for ln of x, one of the special thing about it is it's a logarithm, and logarithms, you can never put a negative number into them. And so ln of x has to be greater than 0, so therefore x is greater than 0, which, as you can see, is the same as the condition for the range of the original function. So let's have a look at the mark scheme. You take logs of the equation, must be correct use of logs. Yep, that's what we did. And then you just shift the 4 over, reduces the correct domain. So yeah, they just put x is greater than 0. Obviously you'd get away with that, but this is just a good thing to have, just to be a bit more complete, especially since they put it in here. But yeah, you're completely fine to just write that. I just like to be careful, and it's a bit fancy as well. So yeah, show off to the examiner, make them think that you know what you're doing. Question 5. So question 5 is parametric equations. Show that dy dx equals that. So we've got a differential. Now the problem with this is you can't get dy dx straight away from these equations. You have to first differentiate them individually. So because this equation, the subject is x and the the variable is t, and so if you to differentiate it, it's going to be in terms of t, dx dt. So let's do that. So we've got 4 times t to the 2 to the minus t. So the problem here is not the 4, it's 2 to the minus t. If you're trying to differentiate a to the x, that's going to become ln a to the x. Okay, that's just it could be in the formula book, I'm not sure, but that's just a thing that you got to learn. Just rewrite that. But in this case, our a is 2 and our x is minus t. So you've got to actually use the chain rule. So first of all, we're going to have to include that 4, and then let's do the differential of 2 to the minus tx. So a to the minus t, sorry, a to the x, 2 to the minus t. So ln a, so that's just ln 2, a, which is just 2, to the x minus t. But we also have to times by minus 1, because that is the differential of minus t. Because this is in terms of x, but this is in terms of t, so you have to times by dx dt to cancel that in a chain rule. In case you don't know how that works, let's write it like this. We have 2 to the minus t, and I'm going to make the substitution that u equals minus t, so then we can write it in terms of u, 2 to the u. Du dt is minus 1. And then if we differentiate this, we can't differentiate it in terms of t, we've got to differentiate it in terms of u. And in case you don't know what this notation means, this literally just means differentiate whatever's in here in terms of this. Okay? So yeah, if we differentiate that, we can use this rule here. So 2 to the u times by ln 2, but we want it in terms of t. So what we have to do is we have to times this by du dt, because if we do that on both sides, as we're going to see, so that is that, and that is that. I've just done the same thing. Obviously they're equal, so if I times by both sides, that's going to be the same. What's going to happen here is, although differentials aren't fractions, they do act like them. So what's going to happen is this is going to cancel with this, and you're going to be left with d2 to the u dt, which is this. Now we've still got a u here, so all you have to do is you substitute that u for the minus t. That's literally all I've done here. As you can see, 2 to the minus t, then 2 times by minus 1. Honestly, this should just be like in your brain whenever you're doing differentiation. If it's not just t, or if it's not just a single unit, you've got to use the chain rule. And then you have the plus 3, which obviously just disappears because it's a constant. So that's our dx. I'm just going to clear the board and write that down. So this may be a bit new to some people, but x dot is the same as dx dt. One downside to this is you don't know what it's differentiated in terms of, but if you're paying attention, you're the one writing it, you should know what it is, and then you won't be like marked down for using this. I use it often just to like save space because, you know, dx dt is a fraction and that could take up a bit of space. So let's differentiate y in terms of t. Now we have a very similar thing, but in this case, it's gonna just be ln 2 times t, 2 to the t, because you know, the 3 is the 3, the ln t, there is no minus, so we don't have to times it by -1. We can just, you know, keep it as it is. That's kind of obstructing that. Well, now I'm actually going to write these again in terms of what they actually are to demonstrate what you do in the next section. So, you know, I'm looking for dx dt, but I don't have that straight away. So how do I get dx dt from this? Well, you know, they aren't fractions, but they act like fractions. So if I do dy dt times by dt dx, which is just the reciprocal of this function, I'm going to get dy dx. So let's plug in that. So dy dt is 3 ln 2 times 2 to the t, and dx dt is 1 over minus 4 ln 2 times 2 to the minus t. So there we go. I'm just going to tidy that up and bring this over here. Okay, and now there's just some simple cancellations. There should be a minus. So ln over ln, yeah, cancels. 3 over 4, that's just going to be you know, minus 3 over 4. And then just be a little bit careful, not too difficult to do this, but indices, if you're dividing by an indice, you're taking away, but this is a minus, so you're adding. So it's going to be t 2 to the t minus t, which is just going to be t to the 2t. Let's just write that down. And that's our solution. Look at the mark scheme real quick. So you differentiate, yeah, so the hard part there would be differentiating the 2 to the minus t. So if you do that, that's fine. You get the two differential equations in terms of t. You divide them and then simplifying to get the answer. Next part of the question, to find the Cartesian equation of the curve in that form. So now you've got this equation, which is the standard, you know, Cartesian form. So in case you don't know what Cartesian means like in terms of x and y, usually. Like that's kind of like what it's not the actual meaning, but that's how I like to think of it. So now what you got to do is you got to integrate. If I were to integrate this, this is still in terms of t, and I've got no x's here, so this is not going to work. So, you know, that's not how we're going to do this. So yeah, we got to actually look at these parametric equations and trying to get them, trying to eliminate t, because we want it in terms of just x and y. So if I look at this, the only common thing is 2 to the t. So I'm just going to rewrite these a little bit. So we're going to have x equals 4 over 2 to the t plus 3, and y equals 3 2 to the t minus 5. I think that's what it was. Yep. So here you can see the common term here is 2 to the t. So really we want to rearrange these so that we have 2 to the t. And then a cool trick that I use quite often, if you have something equal to something over something else, and you're trying to make this a subject, or you can just literally swap these. It saves a bit of time. but I'm sure, like, yeah, people probably know that. So yeah, 2 to the t equals 4 over x minus 3, and then doing the same thing on here, so y plus 5 equals 3 times 2 to the t. So 2 to the t is y plus 5 over 3. Nice. So now we can equate these two. So we're going to get 4 over x minus 3 is equal to y plus 5 over 3. And now it's just a simple, getting it into this form. So first things first, we've got to get rid of these fractions. So we're going to have to times by x minus 3 and 3. So on this side, we're going to times by, I'm just going to times the top here by 3 and times this by x minus 3. Get rid of these. So we're going to get 12 equals x times y, xy, 5 times x plus 5x, minus 3 times y minus 3y, minus 3 times 5 minus 15. So there's one more step to get it into this form. We just got to move the 15 over. So 27 equals xy plus 5x minus 3y. Now, obviously they've got it the other way around, but it doesn't really matter. So looking at the solution, they've actually rearranged it in terms of t to the minus 2. Sorry, they've rearranged it, the y1 for t 2 to the t, and the x1 for 2 to the minus t. And then they have eliminated t by dividing them. Oh no, by timesing them. Yep. So I guess that's like, a bit more of an easy solution. But the point is you got to try and get rid of that t. And then it's just rearranging, which is really not that difficult. Next question. Now, this may look a bit intimidating at first because, you've got a fraction, a third, and you've got 4 plus x. But really, it's just knowing how to get it into the form of 1 plus x to the n. Because that's what you're given in your formula book, which you can just substitute for n and x, and you can work out them pretty simply. But it's just trying to get into that form. So the first thing to notice is we've got a power here, but we don't have a power here. So, the first thing is root is the same as the power of a half, and since it's a fraction, you can just stick a minus on top of that and that'll be the same. So we can rewrite this as 4 plus x to the minus 2, the minus a half. If you don't know why I can do that, why the root is a half, maybe look up indices in your revision notes. But really, you should be able to do this by just looking at it. But the biggest problem here is that 1. We have a 4 here. So in order to get that 1, we've got to kind of divide by 4. But you can't just straight away divide by 4 because you've got that power there. So the way I like to imagine it is, instead of dividing, you're timesing by a quarter. But you need to have the same power. So if I times this by 1 over 4 to the minus a half, what I'm essentially doing is, since I've got the same power, I can just use this within here. And so I'm just going to get 1 plus x over 4 to the minus a half. Another thing, so yeah, there I've got my 1, I've got my power, and then I've got x. Because even though it's x over 4, I can still, substitute it in for x. So it's almost like a huge substitution. But, another thing to take note, because it's binomial expansion, this is strictly such that the modulus of x is less than 1. Because it doesn't say anything else, we can just assume that x is going to be less than or equal to 1. But it may be something that you have to be aware of later in the question. So maybe just have that in the back of your mind. But anyway, so now we've got to actually use the formula. So the general formula, we only want the first 3 terms. So first term is 1, second term is nx, third term is n minus 1 x squared, and then over 2. So let's substitute what values we have. So we have 1 is just going to be 1. N in this case is minus a half. So minus a half. Always put brackets because you might get confused with your minuses, and you don't want to lose easy marks just because you didn't put the minus in correctly or whatever. Now the x in this case, as I pointed out earlier, is not x, it's x over 4. So x over 4. And then next substitution, n minus 1, so n is minus a half still. N minus 1, you could substitute it as that, and that's perfectly valid. You may go straight away to say it's minus 3 over 2, but being careful is not gonna be a bad thing. And then be careful here, it's not x squared, it's x over 4 squared. Yeah, so let's just calculate this real quick. So that's going to be minus x over 8. Here we have minus a half. Now, I could do this mentally, probably. It would take me not that long, but I can, whenever you can, just use your calculator. You are allowed to use your calculator, and it's always going to be correct. So as long as you're plugging it in correctly, you're going to be fine. That's giving me plus 3/8. And then here, be careful, maybe. Sometimes you can get caught off by this, but it's actually going to be x squared over 16, because you've got to square both. And then you can simplify this. It's just going to become, that's actually going to be 3 over 3x squared over 128. I'm just going to get rid of that term in case I get confused. But yeah, there's our 3 terms. Next question, next part. Actually, before we do that, let's look at the mark scheme. And this is what sometimes happens. You've got to be careful. From this step, we times by this to get it into this form. However, this now is not this. It's actually that times by this. So we've actually have to times all of this by that 1/4 to the minus a half. Hence, find the first 3 terms of the binomial expansion of 1 over root 4 minus x cubed. The important thing here is hence, which means you've got to use your first part. So from the first part, we know now to jump from this to that, all I've got to do is replace x with x cubed. So 1 over root 4 minus x cubed is going to be roughly equal to a half, there's no x's in there, minus x cubed over 16 plus 3x to the 6, because x cubed squared is x to the 6, 25, 256. And the reason I knew it was going to be nothing too hard is because it's 2 marks. There's not going to be much you're going to do. And here, is exactly what we get in this. Wait, what? But that's a plus x, so we actually do minus x cubed. So this is actually going to become a plus, whereas this is just going to stay. Sorry if that wasn't clear enough. The original equation is 1 over 4 plus x, but here we have minus x cubed. So that's r plus x. So we have to replace by minus x cubed. So here, minus x cubed is going to turn that into a plus. But here, because it's squared, it's still going to be a plus. Just a little thing there. Again, we've got to use part B. Find an approximation to that. So, where can we use part B? Well, we can just replace that with what we got. So we can rewrite this as 1/2 plus x cubed over 16 plus 3x to the 6 over 256, I think it was. Yep. Dx. Now, like I always say, use your calculator wherever you want, wherever you can. There's nothing here to say that you can't use your calculator to work this out. So I'm literally just going to plug that into my calculator, get to 7 different decimal places, and that's literally it. So that is 7 decimal places. The next one is a 0, so then rounding. So if you want to just, make it super clear, there's your answer. The mark scheme is actually saying you gotta integrate at least 2 terms correctly. So really, I would actually lose marks here. So I'll lose 1 mark, which is not devastating, but I guess the key here is it's 3 marks, and I've already done 2 marks worth of stuff. The first mark being identifying the substitution, the second mark being the actual answer. So method marks, they exist. Honestly, I thought you could just just show it because it's calculator, but I guess not. So do your method. But that's just simple integration. X, they're just polynomials. So. But I suppose I'll go through it. X over 2 plus x to the 4 divided by the new power, so it's going to be 64, not 164. 3x to the 7, that's going to be 1792. Between 0 and 1. Whenever I have these kind of, you could do substitute 1 and then take away when you substitute 0. One thing to notice here is whenever 0, it's just going to be 0 anyway, so you can just substitute 1, which will just make it so much faster. So it's 1/2 plus 1 over 64 plus 3 over 1 over 72, which is going to give you that. I guess you could just plug it in your calculator to check, because this was going to be always correct. So if that doesn't match with that, you can be sure that you've done something wrong here. But as long as you've obviously wrote it into this correctly. But yeah, it's just little things that sometimes get you those extra marks. Part D. Edward, a student, decides to use this method to find a more accurate value for the integral by increasing the number of terms of the binomial expansion used. Explain clearly whether Edward's approximation will be an overestimate, an underestimate, or if it's impossible to tell. Actually, before we look at the expansion, is try to see what the question is asking. Or explain clearly whether Edward's approximation will be an overestimate, underestimate, or impossible. So those are 3 options. Over, under, impossible. Now, usually it's not impossible to tell. So that's kind of like my last resort. That's the one I'm trying to prove last. I'm going to look at overestimate and underestimate first. Alright, so I actually looked at what I was going to say for this part of the question, and it was wrong. So obviously I can't show something wrong, so I'm going to try and correct it here. Basically, we were looking at if the binomial expansion was an underestimate, overestimate, or if it was impossible to tell which one it was. Imagine we're trying to get to some value of y. So there's our y-axis. There's our x-axis. Now, what a binomial is technically it's just a polynomial, which is just a curve. So you've got your x squared, you've got your x cubed, and then that's not quite right. X to the 4. Basically, a polynomial is eventually just going to be a squiggle. But when you put values into a polynomial, they're going to pop out an integer. So I don't know, when x is 1, x squared is 1 as well, but x squared is 2, x squared is 4. What we're trying to do is we're trying to use some polynomial, plug in our value of x to get some value of y, and we're trying to get that as close as possible to this target value. Now, if that didn't make sense, then I hope this next part is just going to make it a bit more sense. If we are currently, a binomial expansion, it's never going to be equal to your actual thing. It's always going to be roughly equal to. And so you're never actually going to get to that value exactly. So if it's an underestimate, you're constantly going to be underneath that value. However, with each step that you add, so each new term in the binomial expansion is going to be a bit more accurate. And so if you're below that value somewhere here, to increase that accuracy, to get closer to that actual value, you're adding something. So the way you think about this is because I'm adding a term to my binomial expansion, a positive term, I am getting closer to the value, and so that must mean that my binomial is an underestimate. And so the opposite is true for an overestimate. An overestimate is always going to be above your value that you want to try and get to. So to get closer to that value, you're going to decrease. So you're going to take away some kind of value. So if we look at what we had before, these are constantly being added. So what that implies is that we have an underestimate because we're adding things to get closer to that value. Now, if these were minuses, then we would say that's an underestimate. If we didn't know, if it was the third option of it's uncertain whether it's an overestimate or underestimate, what that means is our function to try and find that value is constantly fluctuating between above and below, between an underestimate and overestimate. So at no given point do we know, are we at this point where the next step will take us down, or at this point where the next step will take us up. And that would look like if you had, I don't know, something like this, where you're changing between plus and minus. I don't know, minus something, whatever. And that if we had it in that form, then the safest thing to say is that you don't know. So all that's left to do is put this into words. So firstly, you got to show that, or you got to say that you're adding positive terms. So simply put, each term is positive, and then you got to explain that because they're positive, you're getting closer to the value from below, and so you've got to be an underestimate. Therefore, each term increases the value, and so must until the expansion is an underestimate. Now, this is not a formula or anything to to write it in this way. You can, as long as it makes sense, I'm pretty sure you'll get the mark. But even if you don't, this part of the question was only 2 marks, and you don't need it for anything else in the question. So you know, if you're stuck on this part, just skip it and come back to it if you want to try and, you know, try and have another go at it. But honestly, if you don't know how to do something in an exam, then you just gotta let it go. And, you know, because there's no point in wasting time on something you don't know when you could be using that to get the marks elsewhere. And you just gotta know when to do that. Anyway, next part. And last part of this question, I think. He uses expansion to find approximation for this. Explain why this is invalid. Now, first thing that comes to my mind why this could be invalid is because of this condition of x. If it's in a set 3 minus x to the 3, it's got to be greater than 0, which is fine for this range. So, but my second thing is we're using the binomial expansion, and if you remember, well, first of all, x is going to be less than 1, but that's x in the general formula. If we go back, you can see that we have x over 4. But that's for this formula. We then substituted it for minus x to x cubed. So really, what we're looking for is the condition that minus x cubed over 4 is less than 1. Now, you know, minus x cubed, it's just going to be, well, the modulus of that, it's going to be x cubed over 4. I'm going to times it by 4, so x cubed is less than 4. Modulus of x cubed. And so 4, when you have a modulus like this, you can just write it as this. Now if I cube root both sides, we're actually going to get something less than minus 2, because, well, minus 4 is 2 to the 2, so if we cube root that, that's going to be less than 2. But obviously you can just do it on your calculator. So we've got cube root of minus 4 is minus 1.58, blah blah blah. But, you know, and then you're going to have the positive version, which is clearly outside the range, because minus 2 is down here. So I think writing that would be enough, but obviously for completeness, just write, you know, the value of minus 2 is doesn't fit within the range of accepted x values. And that's literally all it is. Only, you know, 2 marks, so it's not going to be too difficult. Hopefully you can understand where I got this from. If not, maybe look in the binomial notes, and it's really just all about the condition that the modulus of x is going to be less than 1. So yeah, but again, it's 2 marks. So if you can't do this, skip it. Come back to it later. Question 7. 3 points ABC, coordinates, blah blah blah. Show that the angle is a right angle. First things first, you want to really draw it out, and you're trying to show that that angle there is a right angle. If that's a right angle, then a squared plus b squared is going to be equal to c squared. So all you got to do is you got to find those values and show that that's how it is. Now, b is equal to BA, which is actually a direction vector, which is denoted by this, but you can just treat it as a distance. Because we're squaring it, it doesn't really matter which direction you do it from, so that's the same as AB. Well, technically it's the negative of it, but because we're squaring it, you know, that minus 1 disappears. So you would do that for all of these. So let's just do that. 15 minus 8 squared plus 10 minus 17. Make sure that you're doing if you're starting from one point and you take away the other, make sure you do it for both coordinates. otherwise you'll get a wrong answer. So that's going to give us some value. Let's just quickly do it. So that's going to give us 98. A squared is going to be BC squared, which is going to be minus 2 minus 15 squared plus minus 7 minus 10 squared, which is 578. C squared is AC squared, which is minus 2 minus 8 squared plus minus 7 minus 17 squared, which is 676. Now A squared plus B squared equals 98 plus 578, which is 676, which is C squared. Therefore, right angle. Yeah, which is it's a bit of work for 3 marks, but once you draw the drawing the actual thing is really useful, and so then you can just pick out the Pythagoras theorem, and then it's just knowing how to get that distance in turn from the coordinates. It's just taking away one coordinate from the other and squaring. Now, that's not the only way you can do that. Maybe if you did the gradients and then showed that dividing the gradients would give you -1, because gradients at a right angle are the negative reciprocal, so if you times them you get -1. Another way could be using, well, if you do further maths, using the dot product to show that would be 0, but generally this is probably the solution you're looking for. A, B, and C lie in a circle. Explain why AC is the diameter of the circle. So this just goes back to the GCSE actually. If you recall, you can draw this, but A, B, C. So that's a right angle we have established. If you have a triangle that has points on the circumference and one of the angles is a right angle, then the edge opposite that is going to be the diameter, which is called the angles in a semicircle, if I remember correctly. But you can just explain it, and that will give you the 1 mark. Determine whether the point D lies inside the circle or outside the circle. Fully justify your answer. Okay, well, there's nothing that really jumps out at me straight away. Nothing jumps out, but we do have a few pieces of information. In the first part, the part just before this, we established that the diameter is AC, and we know that AC has the length 676. Therefore, the radius, that's AC squared, isn't it? AC squared has that length. So the radius is going to be that, because it's half the diameter. We can also find the center of the circle, because it's going to be halfway between A and C. And so we can do that by looking back at A and C. So let me just actually pull those back. To find the center of 2 points, you add the 2 points and half. So 8 minus 2 over 2, that's your first coordinate. 17 minus 7 over 2, that's your second coordinate. in other words, that's going to be 3, and that's going to be 5. If D is on the circle, then the distance from the center of the circle to D is going to be exactly the radius. If it's inside, it's going to be less. If it's outside, it's going to be more than the radius. So really, we've got to see what that distance is, and is it greater than, less than, or equal to the radius. So how do we do that? Well, it's the same process. So the distance between 2 points is going to be 1 minus the other squared and then square rooted. So the distance squared is going to be 3 plus 8, because we're minusing minus 8 squared, plus 5 plus 2 squared, again minus 2, and that's going to give us 170. But remember, this is the distance squared. So if we square root that, we're going to get root 70. Might be actually useful to see what this is. Oh, it's 13. So, you know, if we square root this, so root 70 is, we're trying to make it check, is it greater than 13? Best way to do that is probably just to square both sides, and that's 169. So it is greater than 13. So then the outside the circle. If it was 169, then it would be on the circle. If it was less than 169, it'll be within the circle. Question 8. The diagram shows a sector of a circle OAB. C is the midpoint of OB. Angle OAB is that many radius. Okay. All of the information. So you want to really pick out all the information. So OAB is a sector of the circle OAB. So this whole thing is a sector. In other words, this length here is the same as this length here. C is a midpoint of OB. So this length here is the same as this length here. Angle OAB is that. Okay, that's already there. Given that the area of the triangle OAC, so that's this triangle here, is equal to 1/4 of the area of the sector, show that theta is 2 sine theta. Okay, so in other words, the area of triangle is equal to 1/4 of the area of the sector. So what is the area of the triangle? Well, what have we got? We got half AB sine C, I think, because we've got two. Although we don't know what length these are, we know that they are, you know, connected to these lengths. In fact, we know that this length here, let's say this is x, then this is going to be x over 2, because it's exactly half. So we can write that in terms of these. So let's use the formula half AB sine C. So half A, let's just go with x, B is going to be half 2, and then sine C is going to be sine theta. So that's the area of our triangle. This should be x actually, which simplifies to x squared sine theta over 4. Area of a sector is half r squared pi, half r squared theta. So half r squared this, we're going to get half r, we're going to say it's x, so x squared theta. So that's that, and what we're saying is that t is 1/4 of s, so 1/8 x cubed theta is equal to x squared sine theta over 4. Not too difficult to get to this next part now. Both of them have x squared, so we can cancel. multiply it by 8, we're going to get theta equals 2 sine theta. And really, you just got to know what the two different formulas are for a triangle and a sector, and using the information you're given with lengths, you got to really correlate them, trying to find that link. And don't be afraid to label stuff. If it helps, it's good that you've done it. So yeah, I'd say that's a pretty nice easy 4 marks there. Use a Newton-Raphson method with theta 1 equals pi to find theta 3 as an approximation for theta. Give your answer to correct decimal place. Well, first thing, you got to know what that method is. So that's n minus f of n. So n2 n1 over f of and then differential of f of n. So Newton-Raphson method, I've got it written here, but it's important to find out what f of x actually is. So we have the equation equals 2 sine theta. Now, what we're looking for is something that equals 0. So, to do that, I'm just going to write 0 equals 2 sine theta minus theta. And that's going to be our f of theta. Because what this does is it's trying to get to 0. Trying to find what would give you the root of this equation. So yeah. Then we have to find the differential of that, because that's what we need for this part. And that's not too hard. So we have 2 cos theta, and then minus theta, that's just going to differentiate to minus 1. Next we plug it into the formula, so we have theta n plus 1 is going to be theta n minus 2 sine theta n minus theta n over 2 cos theta n minus 1. And then all we've got to do is we've got to plug in what we know. So theta n, we have theta 1, so if n is 1, then this is going to be 2. So theta 2 is going to be pi minus 2 sine pi minus pi over 2 cos pi minus 1. So, plug this into a calculator, and then, to do the third one, you literally plug it back in to get your last one. You don't actually have to show you plugging it in, so as long as you do it once, it's fine. So I'm going to just do that. It's very useful to use the solve function on your calculator, because you can just replace it with a new value. How many places? 5. 2. So do one more just to make sure, and then round it off. So 1.91132 to 5 decimal places. There we go. Next part, given that that is the value of theta to 5 decimal places, find an estimate for the percentage error in the first part. Percentage error, it's not too difficult. You can probably just figure it out. But I always use this kind of formula that I've made for myself, and it just guarantees that I get the right answer every time. So the formula is 100 times the absolute value of 1 minus the thing you're trying to compare to versus the real value. So the real value in this case is 1.89549, and the value you're trying to compare is what we figured out last time. So 322, and that's it. So yeah, that's going to give you a value just below or just above 1. If you take that away from 1, it's just going to make it into a percentage, into something that's less than 1. And then modulusing it, it's going to account for if it's above or below. And then the 100 is just going to make that a percentage. So that's going to give you 0.93537%. But you only need to do it to a few decimal places, so 0.935. So yeah. Number 9, an arithmetic sequence has the first terms a, common difference n, d. The sum of the first 36 terms of the sequence is equal to the square of the sum of the first 6 terms. So that's the case. So for this, really, you've got to know your sums of arithmetic sequences, and then it's saying the sum of the first 36. So sum of the first 36 is equal to the square of the sum of the first 6. So that, and all you got to do is you got to plug in, for your different values. So s of 36 is going to be a half times 36 2a plus 36 minus 1 d. Sx squared is going to be a half times 6 2a plus 6 minus 1 d squared. So that's 18 2a plus 35d equals 3 2a plus 5d all squared. So that's going to be 36a plus 630 d equals 3 squared is 9, 2a squared is going to be 4a squared plus 10ad times 2 because it's twice. So in case you don't know what I'm doing there, I'm squaring this out. So 3 squared is 9. Then I'm squaring this using the binomial expansion. In case you, for some reason, not really used to this, a plus b squared is always going to be a squared plus 2ab plus b squared, and that's literally what I'm doing here. So a in this case is 2a, 4a squared. 5 times 2a times 5d is going to be 10ad, but there's 2 of them. And then b squared is going to be 25d squared. And then it's just going to be a matter of expanding. But if you can make your life a little bit simpler. If I look at the thing it wants me to put it in, I've already got this term. It's just times by 9. So all I've got to do is divide by 9 on both sides, and I'm actually going to get the same thing. So 4a plus 70d equals 4a squared plus 20ad plus 25d squared. And that's exactly what is up here. Given that the 6th term of a sequence is 25, find the smallest possible value. Nth term is going to be a plus n minus d. And it's saying the 6th term is 25, so u6 equals 25, which is a plus 5d. So now we have two equations with a and d in them. And so we've got to combine them in some way, because that's the only way we're going to find a possible value of a. it's going to be a bit interesting to combine them because we've got a polynomial and a linear equation. But there's a quick win here. When we were doing this expansion here, we have 2a plus 5d squared is equal to that. Here we have just a plus 5d squared equal to that. So we know that 2a plus 5d squared is the entirety of this right side. So what we can say is that a plus 5d squared is equal to 4a squared plus 20ad plus d squared, I think it was 25d squared. And so, but we know what the value of this is. We know that that's 25. So we have a plus 25 squared equals that. But we also know that that is equal to 40a plus 70d. So 40a, so 4a plus 70d is that. And now we've just got to replace, you know, we've got a and d. We've made it a bit more simpler, but we've still got a d here, and we really don't want that. So if I rearrange this to say that 25 minus a equals 5d, then we have a plus 25 squared. I'm going to move that 4a over there, minus 4a is equal to 70d, which is the same as, no, just check this, yeah, it's the same as 14 times 5d. So a plus 25 squared minus 4a is actually going to be equal to 14 25 minus a, because 5d is 25 minus a. And now we all have it all in terms of a, so we can literally just expand this and convert it into a quadratic. And that's really what I was trying to aim. I was trying to get only something that's only got a in it. A squared plus 50a plus, I'm just going to write this as 25 squared because I can't be bothered to expand it, and it's going to be a constant I can just plug into my calculator. Minus 4a minus 14 times 25, same reason. Be careful here, it's minus 14a, so it's going to be plus 14a equals 0. And that's, you know, it's a quadratic when you simplify it. So let's do that. A squared, 50 minus 4 plus 14 is going to be the same as 50 minus 50 plus 10, so that's going to be 60a. And then we've got 25 squared, so 25 times 25 minus 14 times 25, which is going to be the same as 11 times 25. But you know, you could keep it as 25 squared minus 14 times 25. If you're unsure about that, you're going to get the same answer. I'm going to plug this into my calculator anyway, and I'll see what I get. So my calculator gives me a is minus 5 or minus 55. So you know, sometimes you might need to fact check to see, does this make sense? Which you could, if you really want to, you could substitute it back in to this, find out what d is, does it work with everything else. But I know that these are going to be correct. It makes sense because they can be negative, they can be, you know, it's just going to be a different value for d for each of these. But question is find the smallest possible value. So all you're going to do is you're going to say A is minus 55. And that's that. If you look at the mark scheme, it starts off exactly the same as we did. And then it just straight away substitutes it into that first equation that you had, and you simplify that. Now, if you want to do that, that's absolutely fine. It's just going to be a bit harder to, go through all the algebra. Maybe not even, but, with the little thing that I did here, it can actually be a bit confusing for some people, what I did there. So, just substitute it straight away. Substitute for D straight away, if you really don't know. But I found this a bit easier to, visualize. The main point is you're trying to get rid of D in this equation that you're given here, because you're going to get some polynomial of A, which is exactly what you're looking for. Here you're trying to find A, and the fact that it says smallest possible value, it means it's probably going to be more than one value, so a polynomial. Yeah, that's really all I've got to say about that question. Next question. Scientists research the effects of caffeine. She models the mass of caffeine in the body using that equation, where M0 milligrams is the initial mass of the caffeine in the body, and M milligrams is the mass of the caffeine in the body at T hours. So, just from that, obviously this is going to be an exponential decay question, but the important thing here is T is in hours and M is in milligrams, so it's always good to know your units. On average, it takes 5.7 hours for the mass of the caffeine in the body to halve. So, in other words, the half-life of this exponential decay is 5.7 hours. 1 cup of strong coffee contains 200 milligrams of caffeine. Scientist drinks 2 strong coffees at 8 a.m. Use the model to estimate the mass of caffeine in the scientist's body at midday. So midday is 12 a.m. So that's a 4-hour difference. We don't know what K is. And K is it's going to be a constant, but we don't know what it is. However, we have enough information to figure out what that is, and that is this half-life. What this says is that when T is 5.7, the mass has halved. In other words, M0 over 2 is M0 e to the minus 5.7 K. So all I've done there, substituted T for 5.7 and substituted M for M0 over 2, i.e. half of the original value. Now through some simple simplification, cancel those, take logs of both sides, we're going to get minus ln 2, because remember that's 1/2, and that's the same as saying 2 to the minus 1. If you take the ln of 2 to the minus 1, that's the same as minus ln 2, so minus ln 2. Here that just cancels with the e, so 5.7k, and so k is going to be ln 2 over 5.7. Yeah, you could probably write that as a decimal. I think I'm going to store it in my calculator as a value, just so I have it, because I know we are obviously going to need to use it. It's going to be irrational, so it's not really a good idea to write it down as a decimal, but you can, and then just make sure you use the correct value when you can. So now it's just asking, okay, how much has he got? How much caffeine has he got there? After 4 hours, and he says 1 cup of strong coffee contains 200 milligrams, and the scientist drinks 2 of those. I'm going to assume that there's 0 caffeine to begin with. It doesn't really say that. but we don't get any information as to what else it could be, so that's what I'm going to use. So we're trying to find m, where m naught in this case is going to be 2 times 200 milligrams, e to the minus k, which is ln 2 over 5.7, and then t, which is 4 in this case. So you know that's a constant. You can literally just plug that into your calculator and get the right answer. So I'm going to do that. And it gives you 254.929. I'm just going to say that that's 256 milligrams to 3 significant figures. We can go on to the next one. Scientists wants the mass of the caffeine in the body to stay below 580 milligrams. 480 milligrams. Use the model to find the earliest time that she would drink. She could drink another strong cup of coffee. Give your answer to the nearest minute. Okay, so that's an important little fact. Minute. We've got it in hours. But we have now gonna have to have an inequality. So we have the initial 400, and we know that it's decreasing by ln 2 over 5.7, I think it was. T. We got to account for the drinking of another coffee. So if you drink another cup of coffee, then that's going to add 200 more milligrams, and we want that to be below 480 milligrams. So that's the total amount of caffeine that she would have at the point when she drinks that next cup of coffee, and we want that to be below 480. So we've got to find the time that happens. So first things first, I'm going to shift that over and then divide by 400. So we're going to get e to the minus ln 2 over 5.7 t, that is the worst e I've ever seen, is going to be less than 480 minus 200 is going to be 280, divided by 400 is going to be 7 over 10. Ln both sides, so minus ln 2 over 5.7, t is going to be less than ln 7 over 10, and then just divide by ln 2 over 5.7, but it's minus, so you've got to flip the inequality, and this is actually going to be a negative constant because it's below 7 over 10 is below 1, so that's going to be negative, so this should work out. We're going to get 2.933. Now if that's negative for some reason, it means you've either forgotten the sign somewhere, or maybe you got some of this wrong. So time should never be negative. So if you get a negative sign here, you've probably gone wrong somewhere. Anyway, so that's in hours, however. So we've got to convert this into minutes, which is just going to be times in by 60. So times by 60, you get 175.98. And it's got to be above that, so t is 176. So 176 minutes after 8 o'clock, which is when she's first drank. So how many hours is that? It's going to be 176 divided by 6. divide by 60 minus 60 once is going to be well, it's just going to be 120 plus 56 minutes, where 120 is going to be 2 hours, so that's 10 10:56, so 10:56, and there's your answer. And if you look at the solutions, they have done the exact same thing. Yep, and they get the same answer. Really, nothing you can stray from the path here, I don't think. I think the hardest part is recognizing how to put this into here, and then you just got to be capable to go through with the algebraic manipulation to find this. Be careful of the minus, you got to flip the sign, but really you should be looking for a positive number and it being greater than that positive number, because you're finding the first instance of something. Then you've also got to be careful of what time period you're using. Last part. State a reason why the mass of the caffeine remaining in the scientist's body predicted by the model may not be accurate. The only intake of caffeine is not just going to be your coffee. Maybe they had a snack or something that had some caffeine in. Maybe they had something else. Maybe they went to the toilet, which would, have an effect on how much caffeine you had. Maybe the rate that the caffeine is going away from the scientist's body is not the average. There's a lot of things that you can say about this. And the mark scheme, I think, is probably the best place to find a good selection of answers. So the mark scheme literally states any sensible reason. Like, different people eliminate different caffeine at different rates. Models based on average. Length of time to drink 2 cups may have been different. The time, the amount of caffeine in strong coffee may vary. Basically anything that makes sense. Next question. The daily world production of oil can be modelled using this, where V is the volume of oil in millions of barrels, and T is the time in years since January 1980. Models used to predict the time T when oil will fall to 0. Show that T is satisfied by this equation. T equals T. So when time equals T, the volume of oil is going to be 0. So let's just plug that in. 0 equals 10 plus 100 T over 30 cubed minus 50 T over 30 to the 4. And you've got to rearrange for T, but obviously here you have a cube root and you have T's here as well, so it's not going to be that simple, but just go for it. Those things that I would do is I would divide by 10. Makes it a bit simpler. So expanding that, we get 0 equals 1 thousandths. Now, if I'm looking to put it into this form, there's only T's here, so I've got to somehow get a constant here to become something in terms of T. The only way I can do that is if I divide by T or times by T. If I times by T, I'm going to get T plus T4, T5, and there are no T4s or T5s here. However, if I divide by T, I'm going to get 1 over T, 10 T squared, and 10T cubed. And if I do that, then here's my 1 over T. Here will be my T squared, and then T cubed, well, there's a cube root, which is the one I'm going to be using here. So what I'm going to do then is I'm going to move this over to this side and also divide by T. So we're going to get T cubed, and then I'm just going to multiply by this and cube root, and I should get the same thing. So t cubed is equal to 0 over t, and then I'm just going to cube root it, and there's our answer. So use the iterative formula tn plus 1 with t0 being that to find the values of t1, t2, and t3. Give your answers to 3 decimal places. So this is literally just a substitution question. So t1 is root 360 times t0 squared, so that's 38 squared, plus 162, 0, 0, 0, over 38. And then that's going to give you t1. Now, what I would do to save time is I would just have a blank screen on my calculator, type in 38, press equals, and so that's going to save that as your latest answer. And then what I'm going to do is I'm going to make that formula, but I'm going to put, instead of tn, I'm going to put answer. And so what's going to happen is I'll have that formula in terms of what my last answer is, which is basically what that is. It's a recurring formula. So I'm going to find that t1 to 3 decimal places is 44.963. But t2, I'm not going to use that value. I'm going to use the actual value. So all I've got to do, now that I've written that in terms of answer, is press equals again. So then that's going to give me 49.987, and t3, simple, press it again, 53.40504. And those are my answers, which is exactly what the mark scheme says. I think this is just, can you use your calculator effectively to figure out the next few terms? Can you substitute it in quickly? It's only 2 marks, so it's not really a big issue. Explain the relevance of using t0 equals 38. So the only context that we are given is that this starting date, which we've not used yet. And that's basically saying that's when t equals 0, because t is in terms of years. So if t is 38, what does that give us? 1980 plus 38, which is 2018. Which is the year that this paper was in. So I'm guessing that's what this is about. So, yeah, 2018. And yeah, that's what it says in the mark scheme. But it's 1 mark. So if you didn't get that, no biggie. From on the 1st of January 1980, the daily use of oil by one technologically developing country can be modelled as that. Use the models to show that the country's use of oil and the world's population of oil will be equal during the year 2020. During means it's going to be just above 2020 but below 2030. Okay, so really all you're doing is you're equating the 2 equations that you have. Solving for t here is going to be a bit difficult. In fact, I'm pretty sure it'll be fairly impossible unless you want to use some kind of approximation method. This will be very hard to solve for t. However, we don't need to. What we need to do is we need to show that between 2029 and 2030, the values of these two, one surpasses the other. So we can show that 2029 is analogous to t being 49. And if we plug those in, we get so initially, well, at the start of 2029, the country one is going to be slightly less than the population. But in 2030, when t is 50, we're going to get, which clearly shows that the left side surpassed the right side. And so at some point in between those, they were the same, and you just write something along those lines. Look at the mark scheme. Somehow they've figured out the value here. Don't know how they did that, but the points are for finding that correlation between year and t value, modeling the equations, and then substituting for those two different values, and then showing that there's a change. They intersect at some point between those two time zones. You could use a change of sign apparently as well, where you would just take away one from the other and ensure that it's either negative or positive between those two values. Question 12. With polynomial, prove that that's a factor. Factor theorem, because that's what this is. So if that's a factor, then x equals minus a half is a root, and so plugging that into that should give you 0. So p of minus equals, and I'm just going to plug that in just to check. It's always good to check, but if you're confident that you know what you've done is correct, you can literally just put it's equal to 0. But yeah, it does equal to 0. Those are your 2 marks. Let me just check on the mark scheme to see what that says. Yeah, that's literally the same thing. And you probably should write it out just to be super clear, but that should give you the marks. And then you just write therefore factor. Factorize completely. So factorizing using a linear term, I like to use the bus stop method, but there are other methods that could work. I'll show you the bus stop method, and then I'll show you the other method that could work as well. So bus stop method, you write your term you're dividing by, and then your polynomial in here. And what you're trying to do is you're trying to see what you have to times by to get this. And you're always looking at your highest term. So in this case, our highest term is 2x, and we're trying to get to 30x cubed. So to do that, I'm going to obviously times by 15x squared, and then the x squared column is here. But so I get, so bringing that down here and times in by that, I'm going to get 30x cubed plus 15x squared. And then what I've got to do is I've got to take this away from this. So that's going to give me 0. Minus 7 minus 15 is going to give me minus 22. And then I'm going to bring down this for the next term. So how do I get from 2x to minus 22x squared? Well, I'm going to minus 11x. So minus 22x squared minus 11x. Remember we're minusing that. So that's going to give us 0. minus 7 minus minus 11, so plus 11 is going to become 4x. And then we have the 2 here, and 2x to 4x is going to be plus 2. So there we go, there's our quadratic. And then you can just solve that using your calculator or whatever. That's one method. Another method you could use is, well, you know that 2x plus 1 times by some polynomial, which always has the form of that, is equal to 30 x cubed minus 7x squared minus 7x plus 2. So if you were to expand this, you can just compare the different coefficients and see what you get. But there's a quick way to find out what a and c are going to be, because, well, there's only one way you're going to get x cubed, and there's only one way you're going to get constant. And that's by times in the two highest and the two lowest. So here I can say for sure that 2a is 30. 2a is 30. So then a has got to be 15. Here I can see that 1 times c is got to be 2. So c is got to be 2. And then you can use your x squared terms. So how else am I going to get x squared? Well, I can times ax by 1. So ax. I can times bx by 2x, so plus 2ba. Yeah, that's the only way I'm going to get x squared. And I know that's going to be equal to minus 7, because the coefficient of x squared is minus 7. So we know what a is. To find out b, I can just sub it in. So 15 plus 2b equals minus 7. So 2b equals minus 22. So b is minus 11. And so if I plug in all these values I've got, we've got 15x squared minus 11x plus 2. Which, you know, this can be sometimes quicker. So it's really up to you. But, you know, we get the same solution anyway. What I do like about this, though, is you can make sure that you've done everything correctly, because this last value is always going to be divisible by this, if this is a factor. So yeah. What the mark scheme does, let's see. They have... they don't specify a method. But yeah, they just show that they factorize it. I mean, if you want to, you could probably just put this into your calculator, and you know, it will figure out the roots for you. So then all you have to do is write them in terms of the linear factors. So yeah, prove that there are no real solutions to the equation. So looking at this by itself, really don't know what to do, but this is still part of this question. So it's very likely that it's got something to do with what we just did. And also, I see a 30 something squared here, and there was a 30 something squared before. So yeah, it's just making me think it's going to probably somehow go back to that equation. So let's try and do that. First things first, times by 7, so we're going to get 30 sec squared plus 2 cos equals 7 sec plus 7. I'm just using letters. If you want, you can say s sec x, c is cos x. Just saves a bit of time. Let's put it all onto one side. That's not right. minus 7s minus 7 plus 2 is equals 0. We're really close to what we want, but this should be cubed, this should be squared, this should be s, and this should have no c. So to get rid of that, we'll have to divide by cos, and as you know, sec is 1 over cos. So if we divide by cos, we're going to get 30s squared, s cubed, minus 7s squared, minus 7s plus 2 equals 0. So then that's all going to be in sec. But we know that the solution to this is s is either minus a half, uh, 2 over 5 or 1 over 5, 3, 2 over 5 or 1 over 3. And so we've got to show that sec x can never be any of these. You could substitute each one of these in and show that they don't work, but sec x is invalid for the range minus 1 to 1. And so so sec x, no solutions. And since all of these are between that, so minus a half, 2/5, 1/3, there are no solutions. Another way you can think about it, sec is 1 over cos, so if you draw the cos graph, what's going to happen is it's going to be inverted, so that's going to go like that, it's going to go like that, it's going to go like that, and remember that's 1, that's minus 1, so anything between that is not going to be valid, which is exactly what we just done. Okay, if you look at the mark scheme, that's basically what they've done here. They've just explained it, and then you got to kind of have like a conclusive statement. Yeah. Next question. Company design and logo. The logo is a circle of radius 4 inches with an inscribed rectangle. The rectangle must be as large as possible. Large as possible. That instantly makes me think differentiation, because differentiation is used to find minima and maxima. The company uses the model xy plane, as shown below. Use calculus, so differentiation integration, to find the maximum area of the rectangle. Fully justify your answer. First things first, that length there is 4 inches. But we're just going to use 4 because that's like the standard for this. If I were to focus on this coordinate here and write a general equation for it, that's going to be the general point xy. Okay? The reason I'm using that is because then I can create a condition for the area of the rectangle in terms of x and y, and I can also say something about that point being on the circle. Because the equation of the circle is going to be x squared plus y squared equals 16, because 4 is the radius. The area of the rectangle is going to be x times x plus x, so 2x, times 2y, 4xy. Okay? And then I also know that these two must, they're the same x and y. So if I rearrange this to say that y is square root of 16 minus x squared, I can plug that into here. So the area is now completely in terms of x, which makes it very nice for differentiation. Because what we're trying to do is find the maximum area, and we've got it in terms of here. So if dA dx equals 0, then we find either a maximum or a minimum for the area. But the reason why it's going to be a maximum, because the minimum for the area of this would just be a straight line. An infinitely thin rectangle, if you will. So really, when we're doing this, we're probably going to find the maximum. Anything else that seems ridiculous, it's going to give us 0. So let's do that. Let's differentiate in terms of a. So dA dx is equal to 4x 16 minus x squared to a half. Now the reason I've done it to a half is because you got to have it in some kind of form that you can differentiate, which is, I find, indices much more useful than square roots. And now it's just looking at this and thinking, what could this be, and how do you differentiate? Well, this is actually not true. That's just a still. If we want to find a differential, we're going to have to use the product rule. So I'm going to make u 4x, which will make u prime 4. I'm going to make v 16 minus x squared to the half, which makes the differentiated a half, because I'm taking the power down, 16 minus x squared times by minus 2, because that's the differential of minus x squared. It's chain rule. This is also going to be minus a half, because I've got to take away the power. So then we're going to plug it into the formula, which is uv dash plus u dash v. So 4x, I'm going to simplify that to just minus, because the 2 cancels with a half. 16 minus x squared to the minus a half. And then we're going to add 4, 16 minus x squared to the half. And that's going to be dA dx. Now we're trying to find the maximum, so we're going to set that to 0. So what we're going to get is minus 4x, 16 minus x squared minus 2 half, plus 4, 16 minus x squared to a half equals 0. There's a few things that we can cancel here. First of all, the 4's. Straight away, divide by 4. And then we can actually cancel one of these. Now, I don't really like working in the minuses, so I'm going to cancel that. So I'm going to divide by this. 16 minus x squared to the minus a half. So if I do that, I'm going to get minus x plus that divided by 16 minus x squared to a half divided by 16 minus x squared to the minus a half. So we're going to add the halves and we're going to get a whole. So 16 minus x squared equals 0. And now we have a quadratic. X squared minus 16 plus x. Not the best order to write it, but whatever. And x is going to become, if I plug this in, oh, right. Yep, I messed up. So the derivative of minus 2x squared here is not minus 2, it's actually minus 2x. So that would give this an x. No, it wouldn't. it would give this an x squared. So this would be x squared. So this would be x squared. And this would give a completely different solution. So actually I should probably put this in red. So let me correct that. So there's an x here. That's squared. That's squared. That's squared. So that gives us 16 equals 2x squared. So x is 2 root 2. Which is what they've got here. And then you've got to justify that it's the maximum, which I didn't really do. Although I did talk about it. I don't know why I didn't. Yeah. But the way they've done it in here is they've took a value just below that value and a value just above that value to show the change of sign. And so it must be a maximum. I don't really like that because that's just saying that there's a stationary point between those two. Unless that's meant to be the second derivative, which it doesn't seem like it. I think the best way to show that it's the maximum is just to show that the second derivative is negative. So if I were to... Oh, but then the second derivative is really difficult to write. I think you could also argue that the minimum would just be a straight line. I think you would definitely get points for that if you justified it enough. But they seem to have done a change of sign here, which I guess that works, but yeah, I don't really like that they've done that. Anyway, you'd then have to plug it in to the formula to get the actual area, which is 32. And you'd have to state that. But, you know, these few mocks here for showing that it's the maximum, you can live without them. It's a 10 marker, and if you get 8 out of 10, then, you know, not bad. Also, be careful, like I wasn't careful here. Although, I think if you are fast enough and you go back, it's well worth checking your algebra just to make sure, especially when you get ridiculous roots like this, because usually they're quite nice. Okay, and question 14. Some students are trying to prove the identity sine A. They start off by drawing two right angle triangles. The student's incomplete proof continues. Let DOE equal A and EOF equal B. In triangle OFR, so OFR, that's just triangle, sine A plus B, so that's this plus this, is RF over OF. So that line is RF over OF. Yes, so they're using SOHCAHTOA there. That's fine. Line 2, RP plus PF, RP plus PF over OF. So yeah, that's true. Line 3, DE plus OF, DE over OF plus PF over OF, since DE equals RP. Does DE RP? Okay. DE times something over something OF plus PF over EF times EF over OF. Okay. Explain why. That leads to cos A sine B. Okay. So we're looking for what each of these are. So PF over EF, what is that? PF over EF. So we're considering this triangle. And we've got some measurements in there. So PF over EF. Now, this is likely going to be some sort of to a rule because it's two sides divided. As you can see here, two sides divided, and here we get a sine. So, in a similar way, we're trying to find what that is, and it's trying to be cos A because that's what we're trying to do. So, if there's a way to show that PF, so which is this side over EF, so this side, where oh sorry, that's the triangle there. So that's a right angle. So hypotenuse is EF, and we're trying to get cos, and cos has adjacent, so that's going to be this angle that we're looking at. So we're going to try and show that that angle there is A, because that's what we're trying to get to, cos A. Now, if we look at this, this angle is 90 minus A, and so this angle must also be 90 minus A, and so that's A. So you can show that that's A, cos A, and then we're going to use some kind of similar reason for this. So EF over OF. Okay, so this one's a bit easier because that's literally hypotenuse, that's opposite. Sine B equals opposite over the hypotenuse, which is EF over FO or OF. So there we go, it's cos A sine B. Complete line 4 and 5 to prove the identity. So we're doing sine A plus B, and the identity for sine A plus B is sine A cos B plus cos A sine B. So we're trying to match those. So DE is that, and we're trying to go for sine A. So we need EO, so that's going to be EO. And we also know that this must cancel, so this must also be EO, but we can also check that. So EO and OF, that's hypotenuse over adjacent. So there we go, that fills it in. Explain why the argument used in part A only proves that identity when A and B are acute angles. The way they're set up, this A and B are always acute. I assume that's like what that means. So it's just because of how they set up as a triangle. But let's look at the mark scheme. So part A, you show that the angle is A, and then you can show the rest, which is basically the same. Completing the proof of, yeah, that's just how it's going to be. Yep, explain that it's right angles. Okay, and then another student claims that by replacing B with minus B in the identity for sine A plus B, it is possible to find an identity for sine A minus B. Assuming that identity for sine A plus B is correct for all values of B, prove a similar result for sine A plus B, A minus B. So sine A plus B is sine A cos B plus sine B cos A. we're replacing b with minus b. So that's going to give us sine A cos minus b plus sine minus b cos A. Now, you've got to show how some of you may now you may know that the actual answer to this would just make this negative. But how are you going to get from there? You got to know that cos of minus x is the same as cos x, because cos is symmetrical about the y-axis, whereas sine of minus x is minus sine of x, and that you probably have to say. And so if we replace that here, that's just going to give us sine A cos B minus sine B cos A. And that's our identity. And as you look at the mark scheme, that's exactly what's happened. There's your 3 marks. Your first mark is substitution, second mark is doing this, third mark is completing the algebra. Alright, question 15, last question. Curve has that equation, point A, x coordinate minus 4, point B is x coordinate minus 4 plus h. Plus h, usually used for showing differentiation by first principles. And because it's already on the same, x, I'm leaning towards that already. Show that the gradient of the line AB is h squared minus 12h. Gradient AB is going to be the change in y over the change in x between the points A and B. So, what's the change in y? Well, which is analogous to saying f of x minus f of x plus h. Which is use the first principles, but it makes me feel like there's a quicker way to do this, but let's just go with it as it is. And the change of x is just h, because that's how much it's changed by. So these gonna cancel, and we're gonna get delta y is equal to 3 times 4 squared, 16, so 3 times 16, 48 h plus minus 12h squared plus h cubed minus 48h. So these are going to cancel. But remember, we're trying to find dy dx. So we're going to divide through by dx, which is h. So we're just going to get h squared minus 12h, which is what we got. Last question. Explain how the result part A can be used to show that A is a stationary point on the curve. And I'm assuming this is where the first principles comes in. So as h tends to 0, the gradient, which equals h squared minus 12h, also tends to 0. Therefore, stationary point. And that's really it. yeah, and that's the end of the questions. Now, what I usually do at the end is just go through and try and get any of the missed marks, maybe, or look over working. First priority is going over stuff I haven't done. If I still can't do it, then just leave it. And then trying to make sure everything I've done is correct. With any math question, I think it's really important to be methodical and to highlight stuff where you can. And especially if you don't know how to do something, just leave it out, because you don't want to be wasting time. You want to try and get as much out of this as you can. So you use all your knowledge that you know, and then go back and try and pick out the things that you find harder. But yeah, hopefully this was useful. This took way longer than I thought it would actually take to record. I don't know how long it's going to take to edit. My throat hurts. So yeah, hopefully you got something quality out of this. But if I should do anything else, anything more, then please do let me know in the comments. I'm not opposed to doing other subjects other than maths. But yeah, that's it. Have a good one.